Good to go? All right, sweet.
You should use the bird-headed guy more often too in your slides.
That dude's awesome, isn't it? The plumed head. I love using characters like from way out of the Unicode ranges. Like all these guys. These are all from like the ancient Phaistos disc from Greek.
The Mongolian vowel
Greece?
separator.
The Mongolian vowel separator is awesome, dude. For pen testing, I recommend it.
I got my notes down.
Hello. Okay. So, okay. Yeah, I don't think we probably need it.
But the thing is that it's such a small group, you might not even need it.
Yeah, I'm not going to use it if I don't have to. Can I put it on the floor
Yeah, sure. We can just
so I can have the desk space? Okay, cool. So, I'm Chris Weber with Casaba Security. We've been around for about 7 years. And this is a tool. I'm going to go through a couple tools that we're going to be releasing. This one's ready today, one of them. One of them's still a few weeks out. This is kind of an extension from the talk I just gave about Unicode security, because what comes up a lot is how do you automate and how do you test for this stuff, because it's just sometimes so difficult to pinpoint and figure out. So, two new tools. The first one is called Watcher, and it's basically a web app security testing and auditing tool. So, why this tool? So, right, I mean, we got scanners, web app scanners, and there's some free ones, there's commercial ones. They don't have these checks that we're talking about, and I'll talk about that in a second. At least not the ones I've tried. What we see a lot of times is that the developers and test teams want a quick and painless way to do sanity checks between builds, and pen testers want more hotspot detection so they can find zones that look problematic they can dig into more. So Watcher is designed to be pretty simple to use. It's passive, so it just passively watches traffic. It's unintrusive. It's not like a scanner. It's not going to send any requests. It's just going to monitor all the requests and all the responses that come in. So it's pretty low overhead. Right now there's about 30 plus checks, and I was just going to go through them in this talk. And it's also extensible. We're planning to release this as an open source license, so if people want to contribute checks, that'd be great. We've been contributing checks on it pretty frequently, so every time a new issue comes up, we can implement a new check pretty easily. It's written in C#. It's actually a plugin for the Fiddler HTTP proxy tool. So that is a dependency. So if you've never used that, I've been doing pen testing for a long time. Used a lot of the from back in the day with Peros proxy, and used Burt proxy, Charles proxy, and the Fiddler proxy. So we got a lot of choices. I actually like Fiddler for a lot of reasons, for a lot of its scriptability, the way you can control the UI. You can do a lot of cool stuff with it. So that's why I decided to build this plugin for Fiddler. So I just wanted to go, some of the checks are listed here. Obviously, I want to find some Unicode hotspots related to some of the issues I was talking about earlier. I want to find places where a user can control HTML attributes, right? We want to look for cross-domain issues, like mashup issues, like common in social networking sites, right, where you might be calling script from a separate domain. We want to find insecure issues with cookies, right? Secure flags aren't set on a cookie, or HTTP-only flags aren't set on a cookie. I mean, these could be auditing issues just to provide findings and engagement. They could also, you might have a policy that you need to audit against, in which case you could use these checks and define your own. We're looking for insecure HTTP, HTTPS transitions. places where an HTTP page might load an HTTPS form and vice versa. Also, we're poking at SSL. We're looking for SSL protocol issues. Does the server allow v2 protocol? And we're looking at the certificate to do CRL checking and also to do validation of the cert, expiry times, hostname mismatches, and find those issues. There is some cross-site scripting, hotspot detection, but since it's not really blasting the site like a scanner would, it's not really a cross-site scripting tool, but through the user-controlled HTML and some other checks that we have, we can find hotspots that can lead to cross-site scripting. We'll look at the Flash issues. We're not decompiling Flash right now, but that's in the plans. Right now, we're looking at the cross-domain file to see if it's too loose, to see if I can control it from any domain. Same thing for Silverlight. Silverlight has a similar policy. We're also looking for information disclosure issues, like where a HTTP refer might leak sensitive information when another resource is called, or where a URL might include an email address or some other sensitive information. Yeah, question?
Is this the type of tool that you would chain with your more active scanners and get additional results, or would the active scanning mess up the results from this tool?
That's a good question. So can we chain this with an active scanner and get more results? I think you could. I mean, I would attempt it, yeah. I mean, I didn't really have that in mind, but actually since you brought it up, we started actually working on an auto pwn XSS tool along the same lines, and we started running them side by side to see what would come up. And the user-controlled HTML flags do pop up when you find like places where scripts injectable. So yeah, I mean, I would use it alongside. But if you don't want to go through all that trouble, you could just run it in the background too, and I'll kind of go through that. Oh wow, that slide didn't come out that well. So that's kind of a screenshot of the findings.
How do you interact with the findings for this tool?
I'm going to go through that actually. I think it might be easiest just to demo the tool here. I might need more desktop space. So this is Fiddler, okay? This is the Security Auditor tab. Basically, you put in an origin domain that you want to watch, and you can add trusted domains, which are basically treated as origin. So say you're working on a social networking site, right, and it pulls ads. It's like you're looking at like myspace.com, but you don't want to flag cross-domain issues because it's calling ads.myspace.com or it's calling images.myspace.com. So you could add that in the trusted domains list. You can also use wildcards. So I could just say, I could just add star.nottrusted.com as the origin domain, or I could use it as a trusted domain. So down here is the check panel, and this is where the checks are enabled or disabled. So each check can have multiple issues that it flags, which is why I said we have about 30 plus checks. It's probably more like 30 plus issues. And you can just disable certain checks if you need. Some of them have configuration options that show up down here. Like some of them are just basic regex pattern matching. As far as information disclosure, I mean, we're passive, right? So there's going to be false positives, but you can control that in here. You can control the type of information disclosure you want to look for, right? I want to find all the places where I see passwords sent out on the URL or in the refer. I want to flag all the places where I see an email address flagged on the URL, session ID, leaks on the URL, so that sort of stuff. So I'll go ahead and save that config. It's got a version check right now. And here's the results page. Let me see how well this works. So I got a test page set up. Okay. So here's some test pages we have. So character set issues. are a problem in web apps. I talked about this a little bit last time. We want to make sure that hopefully web apps are using UTF-8. If they're not, they could be subject to different attacks. So here's an example of where this page is not using UTF-8 either in the meta tag or in the content type header. In this case, it's ISO 8859. If you want to, has anybody ever used Fiddler? Okay, so Fiddler provides a lot of customization, and it's an HTTP debugging proxy. So if you double-click on this, you'll jump over to the session inspector in Fiddler, and this is where you have nice parsed-out views of the request and the response. Up here's the request. It's your GET request. This is the headers view, so it breaks down the headers for you. You could look at the text view, which is just a GET request, so there's nothing there. You can look at the raw request, which is just a nice raw view of the HTTP request. And of course you can find stuff. You can look at the hex view. So you got a lot of cool options in Fiddler for how to parse responses and requests. In the response down here, same thing. Here's the headers. You can see I got a content type header, but a char set wasn't set, which is why it was flagged as an issue. If you look at the text view, you'll see there's a meta tag, and the char set's 8859-1. So Fiddler gives you a lot of insight into the that part of it, and it keeps track of the session list over here. Fiddler also has a command line down here, so you can do some cool stuff. You can set breakpoints on specific requests or responses. You can clear the session list. And then Fiddler also has a scripting interface through customizing rules that you can do a lot of cool stuff. You can control the UI pretty much through a JavaScript type of interface, or you can do an extension like we did over here. So back to the tests. So I want to look at the cookie checks and see what's going on here. Now this is the warning you get because Fiddler also provides a way to do SSL man in the middle, so it can do SSL decryption and all that, just like the other proxies do. But you always, the browser is always going to see a different certificate, so you always got to click through to accept the certificate warning. Okay. I think I need a little better resolution over here, but you can see we found some issues with the cookie, a loosely scoped domain, right? This is a common in a mashup situation or a social network where they set a cookie and they loosely scope the domain to the root or parent domain. Since we're at www.nottrusted.com, it would be more precise to set the cookie to that specific domain than to loosely scope it to the parent. So here's another issue where a secure attribute was not set since we're in an SSL page. And this cookie doesn't implement the secure flag. That could be an issue, especially if it's a session cookie. Normally if it's a session cookie, it could very well be a cookie that we don't care about, in which case it would be a false positive and you just want to ignore it. But if it's a session cookie, it's an issue. Same thing with HTTP only. HTTP only is a flag you set on cookies to tell the browser not to let script interact with them. And this is a mitigation against cross-site scripting attacks that try to read cookies or try to send them off to another page. So HTTP only flag should be set normally on any sensitive cookie like a session cookie. And since it's not set on this cookie, we flagged it. I'm going to clear the results. Go check out another check. Cross-domain checks. These are cool. So these should probably be more informational than medium, but the general idea is you got a style sheet here that's imported from a third-party domain. So I'm at nottrusted.com, and we're importing from lookout.net. What's going on with that? We need to now take a look at that style sheet. There may be issues with it. Same thing for script. We're pulling JavaScript resources from a third-party domain. Same thing with JavaScript references. Oh, hey, we got a form that's going across that's posting off to a third-party domain. You know, what's up with that? These are things that are generally hotspots and need a closer look. Let's go to flash checks. Okay, so this is an issue with flash script access. When you call flash, you can set an allow script access flag that tells the browser to allow. Basically, the browser can control if script from the same domain can interact with the flash, or any domain can interact with the flash. So we generally want to see allow script access equal to the same domain or none, and if not, then we call out an issue because I can control this flash from another web page, from another domain, potentially. Look at the cross-domain XML file. You can see in this case it was set to a star, a wildcard. So that's telling the browser that we're allowing access from any domain for this flash. That's generally a problem. Generally want to see that flash restricted to the domain that loads it. Okay. So header checks. Oh, we got an authentication box. I'm just going to cancel that. So let's take a look at the headers we're looking for here. Here are the issues. An insecure cache control header was set because we're on an SSL page. We generally want to see the no store header get set, which tells caching proxies not to store this information. No cache is a little weaker, so we flagged that as an issue. We also saw a blank content type header. This can be, I mean, if you're not setting a content type header, then you're usually forcing the browser to determine what the page content is. And in that case, if an attacker can control anything on the page, they can manipulate it to get a cross-site scripting or other attack to execute. We also found weak authorization. This is just a basic check to see that, hey, you know, basic authentication was happening here on the page. That's not generally a good thing. So we look for basic and digest. So information disclosure checks. So let's look at those. Information disclosure. Hey, there was a database error message that was hidden in this page. Maybe buried in a comment somewhere, something that didn't display visually. I want to know about that. So we basically have a list of strings of common database error messages that we try to match against. I mean, it's not rocket science, but it can help find issues. Some curious comments were found. Hey, look, you know, we look for comments with bug, to do, XSS, some cuss words, some other stuff that we want to take a closer look at. Sensitive parameters were found in the URL, so we're pattern matching on email addresses with regex patterns. So hey, you know, we never want to see an email address leak out on a URL. That's typically a policy violation in any organization. And then a session ID potentially slipped out as well. So we got inside the check down here. There's the number of issues will be listed out separately. So you got one issue here, and then you got the session ID issue also called out separately. And then we found an HTTP referrer leak. So we're looking at the HTTP referrer header in the request. And if you want to jump back over to the session inspector, just double click it, and you can see right here, here's the header that got leaked. If you want to jump to the raw view, you can jump it up in here. You can. Now, I guess one thing about Fiddler, it's also an intercepting proxy. So, you know, you can do all the cool stuff you can do with burp and everything else. You can intercept requests and responses and modify them either way. Or you can automate them. You can use script to tell it to search and replace text, do other stuff like that. So you get a lot of control. Hey, we found another referrer leak here off to a third-party domain. And that's the difference here between a medium finding and a high-risk finding. High risk means if the leak was to a third-party domain, that's usually a big issue, right? Like you called a resource, like an image from a third-party domain, and in that image you included a leak. That's bad. So we'll also call out information leaks to the same domain, but we'll lower the priority on them, or the severity. So JavaScript checks. This is, let me clear the cache. Didn't show up. Okay. So this is like kind of like a policy guidance, looking for dangerous uses of eval in JavaScript or set timeouts and those things. These can lead to cross-site scripting attacks a lot. In some places, they're actually a policy violation to use this because they're so dangerous. So if I have an eval that's taking user input, I got a scripting attack. So these are informational findings and another hotspot to look into. Silverlight checks. These are the same thing. So you got a cross, similar to the Flash cross-domain XML file, right? We want to know when the policy for Silverlight is allowing access from any domain. In this case, it is. It's just a wildcard saying that any domain can interact with the Silverlight application. It's just identical to the Flash. We're actually planning on adding more Silverlight things in here. We want to actually pull down the Silverlight, reflect it, and then start looking for dangerous coding problems inside of it. I got to learn more about Silverlight though to do that. It's going to go to the Silverlight talk. I think that's today. Hopefully get some of that info, and then have some checks for that soon. I don't know. Silverlight's obviously not as popular as Flash, but we still run into it. So SSL checks. Okay, so look at this. Here's 3 issues flagged from this check, these checks. So here what we're saying is we've got an SSL page that's hosting a form that's posting to an insecure page, a non-SSL page, right? That's a problem usually. I mean, the user thinks they're at a secure page, but it's posting somewhere that's not secure. Now, we also look for places where insecure SSL v2 handshakes are allowed. A lot of servers these days are disabling v2, but a lot of them still have it enabled. So SSL v3 should be the norm, so we call that out. We also look for validation errors and naming mismatches, expiration problems. And like I said, if you need to dig in closer to any one of these, just double click on it in Fiddler. You'll jump down here to the session inspector, and you can look at the HTML for the page, take a closer look at it. You can actually search inside the page. I want to find the form. Okay, there it is, right there. Same thing for the request, which is shown up here in the top half. I'm going to go ahead and go back to the watcher interface here. Here's another SSL check. This one. Form load, insecure page. Maybe this one's broken. Here's the flip-flop. This is like what Moxie Marlinspike was talking about at Black Hat. I mean, this has been a big issue for a long time, right? You have an insecure HTTP page hosting a form that posts back to a secure SSL page. That's a problem too, okay? I mean, you got to just end-to-end SSL to be secure. So there's another insecure transition we call out. That's usually a hot spotter, like an auditing finding. Let's go back to the test page. And look for some Unicode checks. So this is a test page that helps you find issues with Unicode byte streams. If you see this in a web page now, I would say there's a problem. If a web page is producing invalid UTF-8, something's going on, and something needs to be looked at. That's usually a big red flag. So here, this check is basically looking at the byte stream from the server, the response byte stream, and it's telling you that at position 481, we found an invalid byte sequence, a C375. And in Unicode, UTF-8 because it's a 4-byte, it's up to 1 to 4 byte variable width encoding. The first byte tells the interpreter how many bytes are in this sequence. C3 says, hey, we got a 2-byte sequence. The second byte needs to be valid for a trailing byte, and in this case it's not valid for a trailing byte. It's a 7-5, which is a normal ASCII character. So position 481, if we jump over to Fiddler, take a closer look at the hex view, we can go down here and we can find the hex position 481 right here, C385, and that's what's going on, and then you can figure out from there, oh, it's over here in this string. Now, if I were looking at a web app and I saw that, I would want to know if I can control that input that set that invalid stream, and if I can probably make some pretty nasty stuff happen. So we can go back over here to the checks. Null bytes in a response. Generally, you shouldn't have null bytes in an HTML page. If you do, it's sometimes indicative of malware. I always call it malware for some reason. And then, all right, so let's see here. Okay. Let's look at the user-controlled checks. Clear the results. This is a good one for finding cross-site scripting bugs, right? There's actually a lot of issues that this page tests. It has a lot of the third-party stuff flagging because if you look at the URL, there's a flag, URL equals http lookout.net. Since we are at nottrusted.org or nottrusted.com, that's obviously a third-party domain. So check this out. We got a potential cookie poisoning attack because the data that was sent on the URL is put right inside the cookie. Now, that's a hot spot because I want to go back and see if I can control that and actually set cookie values that would manipulate the attack. We have what appears to be a user-controllable character set because that information on the URL actually wound up right here inside of the meta tags char set value, right? Now you see that a lot. You see a lot of web pages set like encoding or language tags on the URL, and it just actually makes it right up here to the character set. I mean, if you can control the character set, you can do a lot of damage inside a web app. We have a user-controllable JavaScript reference. Now that would be awesome, right? I mean, okay, it's that easy. You mean I can just send a parameter on the URL, and that parameter is used in the script source of a page? So we have two issues here. One was found in a window.open, one was found in a location href. And we also have a user-controllable tag attribute. Okay, here's the script source tag one. So look at that. The parameter actually controls the script source for a page. Obviously, if it's that easy, it's just game over. I can just load my script source from anywhere I want. And that web application at that point is then owned. Okay, I'm going to clear that list. Open redirects. These are good findings. Usually pretty easy to come by. I mean, if I can control the location header, then I got a great place to perform a phishing attack. I mean, this is how a lot of phishing attacks work, right? They find a URL like this one, where one of the parameters is a redirect URL, and if the redirect URL is user controllable, offsite, and the web app's not doing anything to protect against that, then you have a great phishing attack because you can have google.com//redirect here, and it looks like a legit URL to the user, but really it's offloading to another page to load some malware. See, I did it again, malware. All right. And then there's the old HTTP response splitting attacks, which are mostly fixed these days. But if you can control location header, you usually want to look into those too. So open redirects, we just flag those as high severity, red ball type issues. So I think that's about it for that tool. You guys have any questions? I mean, we plan on putting some more checks into it and working on the Unicode stuff now, but I wanted to get it out before that. We have more Unicode checks coming as well, and then it's pretty easy to put. I mean, this works passively, so there's no intrusive scanning going on. It's just watching everything, and if it sees an issue like a cookie issue or any of these issues, cross-domain, flash, header issues, and we'll flag them. And usually, sometimes they're direct findings, like an open redirect. Obviously, that's a finding. Sometimes they're hotspots you just want to dig into more. But we're trying to originally set it up to like match so we could find policy violations with some of the companies that we work with. You know, they have policies against open redirects. They have policies against sending sensitive data on the URL. And just want to make it easier. I mean, you don't want to have to look at every request manually. I mean, just keep a list here. Once you get the list, you can export it to XML. You can clear stuff that might be a false positive or might be noise. You had a question?
How does this compare to rat proxy, like in the number of tests and that kind of stuff?
I don't know exactly like check-wise how it compares, but I know that rat proxy does definitely look at similar issues. But I don't really know the exact number of checks. I know that there's another tool, Proxmon, that's been out for a while that does some of this, and it's written in Python and extensible too. But basically, like I and my company had a need to look for specific checks that we weren't finding in these other tools, and rather than extend them, we just wanted something that we could have that would be extensible.
This looks much, much more usable than rat proxy, just in terms of like consuming the output of it, because rat proxy just spits out like a whole big long list of stuff that you can manually go through, but this is a lot more easy.
That's how it was designed. It was just designed to be, configurable with some advanced configuration options hopefully coming, but you can control like strings and things that we're looking for in here, full CRL validation of certificates. You can control the domain, but at that point you just click enable and it's good to go. I mean, if you just take out the domain and save it, then it watches everything. So any request to any site. Let's see the source conference site. So, and then you'll see some issues with set cookies. Now in this case it's probably a false positive, right? I mean, so we got a session ID, but it's not really an issue. I'm just an anonymous user on this page. But you'll see it'll watch everything. So you just have it running in the background. It'll just watch every domain. But if you do that, you miss out on the cross-domain checks, because the cross-domain checks are really dependent on knowing the source origin domain. Otherwise, it won't know what a third-party domain is. In this case, the cross-domain checks are nullified because everything's treated as an equal domain. But yeah, Fiddler, I guess you got to be partial. I mean, people have their preference about debugging proxies and things that they like. I actually have been using Fiddler for a while, and like I said, Burp and all the other ones, and I actually like the way it does stuff in here, and you can control stuff. You can hide image requests and use the command line to control stuff and control it through scripting. So it's a lot of power there. Yeah, question. We're planning on releasing the open source, so the source code will be the documentation for a little while until we catch up on exactly what they're doing.
It seems like a lot of the app firewalls or just like even a proxy server might want to integrate these checks.
Mm-hmm. Yeah, the checks are, like I said, they're not rocket science or anything, but they're issues. So and they can all be done passively. That's the nice thing. You can give this to a developer and say, run this, in between builds and see what comes up. And of these 30 checks, I just want to look at 4 because those are our company's organizational policies that we can't do those things. And that's kind of where it was designed to go along those lines.
Seems like on the app firewall side, some other good checks
So that would be like, yeah, looking for SSNs going across the clear, or any URL or a cookie. And that could certainly be done pretty easily.
Not SSL.
Yeah.
As a not Windows user, though, not happy with, or not a very portable choice.
Yeah, we knew we were taking that risk when we created it. But we didn't want to create another proxy, and we didn't want to go with burp because you have to pay for burp, I think. Even though it's Java, it's cross-platform, it's nice, it does a lot of cool stuff, and it's extensible. So yeah, we're kind of stuck with the Windows users here.
Plus you get like a lot of the Windows, like I'm sure you get more functionality because you can do everything Explorer can do. Like I don't know if there's an ActiveX component to this or could be. You get that for free.
You get all the .NET framework for free, which is nice. It makes development easier. Yeah. Maybe Mono. I mean, will Mono support this on Linux or Unix systems? I don't know if anybody plays with Mono.
It depends on if it will run on the Unix system.
Right.
I mean, if it will, a lot of the .NET, well, I won't say most, a lot of the .NET stuff will run on Mono. Not bad at all.
I mean, the only issue I could see is maybe Mono's only up to .NET Framework 2.0, in which case we might have to make sure everything's...
I think they're up to 3 now.
Okay.
They're up to 3.5, yeah, they're up to 3.
I know we saved it as a 3.5 project, and I think we might be using 1 or 2 things that are 3.5, but we could probably change them down to 2.0 if it helped. I'd be interested to see, though, if anybody uses Mono, if we can get it working. Then send me a message. That'd be cool to know. Let's see here. So the other thing was a spoofing detection API. This is something that we're working on. That ties back to the talk I just gave about all the visual spoofing potential, right? We got over 100,000 individual characters in Unicode. There's tons of lookalikes. I mean, spoofing Maximus, you know. And the end user is the one that suffers here. And not just that, but if we can't get it under control, then the future of IDNs are really at risk. And I don't know how many people are aware, but you know, domain name labels support international characters now. So you can have pretty much anything in Unicode available to you in a domain label within some restrictions that the registrars and ICANN set. And it's getting ready to move to the top level TLDs, so they're getting ready to internationalize TLDs too. They've been working with example.test in like 12 languages for a couple years now, and I think toward the end of this year, the beginning of next, we're going to see specific TLDs to specific cultures. Yeah. Oh, yeah, I love that character. I should bring up that presentation just to show those characters again. So here's a solution, right? Confusable detection, invisibles detection, syntax spoofing detection. This might not make a lot of sense. Kind of depends on the the last talk I was going through. But what we're trying to build now, or what we are building, is a cross-platform component written in C. So it will run on Unix, will run on Windows, and then we're going to start applying it soon in browsers and email clients, right? We're going to plug right into it and see how well it works. And we're going to do all that sort of detection. We're going to do the confusibles, invisibles, and syntax spoofing. And basically we're going to end up, this is just a mock-up of what it's going to look like, right? So you're in your browser like Firefox, and this is a spoof I showed earlier. So you're clicking on a link for Mozilla.org. Right now the only warning you get in Firefox for .orgs, because they are whitelisted, which means they show IDNs, down here in the status bar, the bottom left, that's your warning. So this is our warning. Hey, confusable characters were detected in an IDN URL. It appears to be Mozilla.org, but it's really xn -- blah blah blah, because that's the Unicode version of it. Do you want to proceed? Sure. Okay. So here's the spoof page that I created. I actually registered this domain name, by the way. So if you work with phishing people and you want to buy it or something, just let me know. Then there's a lot of your question?
Yeah, I don't know. If it's a small crowd, so maybe I'll just ask.
Yeah.
Maybe go into this later.
Please.
I didn't see your last talk, but this seems really interesting. I thought browsers had locked this down, and maybe this is what you had mentioned, .org versus .com. But I thought the browsers were locked down to their local character sets based on the language.
That's a common perception. It's a lot more. It's a lot more complicated than that. All the browsers are pretty divergent in how they implement this stuff and how they conform to ICANN's guidelines and to the Unicode specifications. So check this out. If you see, okay. So here's my spoofing test. Okay, we've got to go back. Okay, let me go back here. So there, right? Firefox doesn't treat .com so kindly. Okay, so down there in the URL bar, the status bar, you can see it's puny-coded it, right? So I proceed. Now Firefox is going to show you the puny code. A lot of browsers take this route. They say, .coms, I don't trust them. Let's just puny code it, ruin the IDN experience for users. Some browsers, though, let's go over here. Oops. So Safari and Opera. You can see down there in the URL bar, bottom left, google.com. Google.com. I made that page for my mom.
There's
So.
no warning in Safari then.
Yeah, there's no indicators, there's no warnings. It's about as bad as the economy. So. What's that?
It's up to 7,000.
Oh. We're back, yeah. Back in the game.
And that's handled differently per TLD?
It's a combination of TLDs, installed language packs. Yeah. It's
So in Firefox, it works differently for .com versus .org?
right. So go back to Firefox.
Why that is varied?
It's each user agent decided to implement IDN a little differently. If you go to what is it? About config. Oh, I'm in Opera now. Sorry. Okay, so yeah, Opera has the same thing, and Opera's a little different too. Let me just open up the IDN spoof page. And Opera, they're pretty kind. You can see it looks like google.com and Opera too. Okay. Oh, .orgs. Well, I'm going to be kind to those too. This is the same for Opera and Safari. And then even down here, this is an example of a syntax spoofing, which looks different and better in other browsers than it does in Opera. Right now that slash is pretty obvious, but like to my mom or your dad or something, it's probably not so obvious. I was going to show Firefox because Firefox has the about config page, and if you type in IDN, you get look at all these. These are all the TLDs that are whitelisted in Opera by default. Okay, sure, ACs, cats. People think you need Some people assume you need a CN to pull off an IDN spoofing attack, and what I'm showing is you don't. You can do it with a .org and a .com. .es's, these are all whitelisted TLDs. Okay, there's .org. This is out of the box. I don't even know what these are. These are some puny-coded whitelisted things. IDN's enabled, which is cool because it should be. And there's a blacklist of characters for syntax spoofing. They're trying to prevent some of the syntax spoofing lookalikes, like the box characters and the slashes and other slashes, which is why I was showing this case here, because there's other slashes that aren't blacklisted, that are valid letters and characters in other languages. Like that's a Japanese character there. Now at a glance, you and I, right, we're scrutinizing because we're security folks, so we don't trust anything, but mom and dad, they're probably going to see that and think yahoo.com. Yeah, so every browser is a little different. I think Safari has something like this under the hood, but I don't know how to get to the configuration of it. So we're pretty much approaching it as a problem that can have a solution, and the solution is a common framework for protecting this cross-platform. I mean, so we're just going to be releasing these plugins and build them on top of an API that's common. So it's common confusables detection API.
And that only ever pops up when it detects something discrete.
Yeah, I'm not sure. If it detects a potential confusable. In this case, like the Google.com, the browsers don't handle it because that G, the lookalike G, is actually inside the Latin family of script. It's not an ASCII character G, but it's a Latin G. So they're allowing characters within the same script, apparently. So, but we want to be more scrutinizing than that. And it's actually a confusable, so we're going to treat it that way.
And how do you fix that? Do you have to do like a visual analysis, render and do a visual analysis, or how can you do that without like looking at all the different character sets?
You can't. You got to look at all the characters and have mapping tables. So we have mapping tables of confusable characters, and all the lookalikes. There for a G.
Does that give you a performance hit when you're browsing the web?
I don't know. Not if we did it just at click time, or we could.
Has anybody made a tool to you enter in real domain and spit out every possible permutation, like using all the different character sets?
That's something else I was kind of working on, but I haven't seen any tools like that. But while we're building the confusables detection, we're also building confusables generation. So
If you knew all the possible, bad ones,
exactly.
you could just filter those out, or at least flag them right away.
Google.com.
Yeah, but I mean, we could have all the different. See, with Google.com, I mean, there's how many possibilities? I should bring up the others.
Well, that's a business model. You go register them and sell them to Google.com.
There are registered
That's a great business model.
So if you go to register domain and you weren't smart enough to check first, it'll tell you that that domain's registered, but the following similar combinations are available, so it gives you options. Some of them are really.
I'll be right back.
Yeah, really.
It would be.
Here's something for you. Here, let me get this. I don't know how much time we have, but this is from the last talk. This is where so we got all the old attacks, like where just a regular ASCII RN can look like an M in certain fonts. Okay, I mean these are all still valid today. Phishing. You got the old monowidth stuff because most browsers do monowidth, like Courier fonts and Lucida fonts in their URL and status bars, and you got the old classic phishing URLs that look all long, login.facebook. And then you got the confusables, and this is what I was doing. There's so many variations. I mean, lookout.net, I'm using a Latin letter CRA. Apple, I'm using a Latin small letter alpha. Then you can use mixed script, right? Like that's tie digit 0 for the O's and Googles. C for Facebook is a Greek sigma symbol. There's Cherokee script to choose from. There's Cyrillic, there's Greek. Lots of fun stuff. And then just wanted to point that out. And this is what's going on with Mozilla. That's a Latin I with an acute above. And then the syntax spoofing stuff. So yeah, I mean, you could probably register a lot of different domains. I mean, the variations on just Google.com are quite a lot. I mean, you'd spend a lot of money registering domains, so you'd have to have a good
And it's usually
ROI.
on someone clicking on a link.
Yeah. Yeah, you can't type those in unless you could do some SEO tricks, right, and push it to the top of the list, which is probably pretty valid.
It's probably more likely to be like a phishing attack where you get redirected to it and you're fooling someone to make them think that they're at the right site.
Yeah, I would.
It's probably much more likely attack vector than having somebody type in some weird.
Well, yeah, that's what I was saying. Like, even if you went to a browser and you typed in Gmail, right, I would have to pull off some pretty good SEO tricks to get my phishing domain pushed up to the top of the list. But I probably could if I was a black hat SEO guy. I mean,
Maybe it's not registering them, but building a system that makes all the permutations and then queries them and then alerts the owner, or alerts the real domain owner
that there's been a trademark violation.
Or maybe a tool that the owner of the domain could run themselves and report to themselves when.
That could be a really good tool.
Yeah, that would be interesting. If you're at Google and you can go and say,
Hey,
you know,
look, somebody
because
registered.
clearly if somebody's registering an alternative name, that's, you know, a trademark violation, you can just send the lawyers after them.
Exactly.
Or, well, the attacker could just pay Google to advertise their website based on.
This is actually, that's kind of where we're going with this. I mean, we wanted to do more than just the IDN spoofing. We want to provide that protection to the trademark owners as well, so they know that there's been a violation. Yeah, so thanks.
So can you show us what we missed in the talk if we have a few minutes? That's so cool.
How much time do we have?
I don't know. Probably not.
I can show you the plumed head.
Yeah, just pull it up. You gotta get that tattoo done. Head sword apple spellseparator.com.
Okay. I'll give you the super fast rundown. See how fast you can go through this. So, Unicode crash course. Unicode's old. There's a lot of stuff that makes up a character. Lots of stuff to attack. We can capture ancient scripts with Unicode. It's not a 2-byte character. Stop thinking that. It's large and complex. This is where I need the theme music from 2001: A Space Odyssey. Dun, 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 dun. Don't use those legacy character sets. ASCII's preserved. There's a lot of stuff that makes up a character. There's the plumed head. This is from the ancient Phaistos disc. There's a lot of cool stuff. Variable width encodings. And then there's a lot of root causes for issues. These are the things that are hard to automate. This is some of the stuff that's going into that Watcher tool, as well as another tool we're working on to try to detect some of these issues. With buffer overflows, I was talking about the maximum expansion factors. I mean, you've got expansion factors of 18-time multipliers with some characters. So that means if you take a character and you normalize it, which is common in Unicode, it's going to expand by 18 times. That happens with uppercase and lowercase operations as well. Let me see here. Oh, here's the invisibles. So you can have invisible characters embedded in strings. They're called like zero width, so they don't take up any space visually. You can use bitty characters to reverse text and fool people. I actually pulled this attack off on a web app. It like popped up a dialog box saying, "You sure you want to go to this domain?" And you just shove in a bitty character and flip the text around so you can control it. .txt's that execute. They look like .txt's, but they're really .x's. Best fit mappings are very dangerous. I pulled this attack off on a social network, gave them a full width M, and they best fit mapped it down to a regular M, even though they were filtering for Moz binding before. I was able to get around their filtering with a best fit mapping. I don't know where they were doing best fit mapping. That's a problem. You always have to normalize after validate, or normalize before validation, and do all your stuff. The 4 normalization forms decompose, and some of them recompose. And decomposition is different, but basically the byte structure changes. So a single character will become 2 characters when you normalize. Some characters get normalized down, which basically becomes a best fit mapping. So you can have a full width, or no, that's not a full width. That's a different, some other character that looks like a greater than that gets normalized to become a greater than. So you can pull off a script attack if you need to when people are normalizing in a web app, for example. Always normalize before validation. Non-shortest form UTF-8. This is the old IIS Unicode hack, right? It still works in some systems. You pass in, that's a apostrophe, right? If you do overlong UTF-8 encoding, it's %C0%AF. That's forbidden by the Unicode standard to interpret that because of the problems that it's caused. There's a lot of ways to represent a dot dot slash other than just encoding it. On the left, I got the normalization forms of it and the best fit mapping forms of it. And I would try these if I was doing any file system operations or web app testing. Here's a list of some. Handling unexpected Unicode is a problem. There's unassigned code points. You can get half a surrogate pair. You can get a special character like the bomb. How do applications handle all this stuff? Here's what happens when an overconsumption attack. I hand you a C2, which is a valid lead byte of a double byte sequence. However, there's not a valid trailing byte. So what do? Do you consume the second byte? Some apps do. Some of them just drop it. Actually, this slide's wrong because that 3E41 below should just be 4141. Yeah, that's a problem. So yeah, the C2 and the 3E are supposed to be consumed together. Yeah, so then you got attacks like this. This attack works in all browsers using multi-byte character sets like Shift.js. I haven't found this problem in UTF-8 for any browsers though. It is a good attack though in other character encodings. Got to correcting insecurely can be a problem. If you delete characters, it can be a problem. If you get the bomb and you just drop it, then you. There's all sorts of ways to bypass filters. This attack works in Safari, actually. So that bomb characters come in pretty handy. Here it is. And then if you look at it, so here's the string. It looks like you'd expect, but underneath it, you see all this nasty stuff over here. EF, BB, BF, that's a byte sequence for a bomb character, and it's pretty much embedded everywhere. href, JavaScript, alert, Safari doesn't mind it.
Do you work with the WAFs? Any WAFs to test the
No, I've wanted to get my hands on some to test some of this stuff, but I don't know any of them. Casing operations. This is a fun time. I mean, you can pull off attacks like this, where this is a Latin capital letter I with a dot above. When it's called onto lower, it becomes a regular letter I, so you can pull this attack off. Length operations, they're not equal. Used buffer overflows. Here's some of the expansion factors I was talking about. Upper to lower, you get a maximum expansion factor of 3 times on a character like this. When you normalize, you can have up to 18 times expansion factors on a single character. This is a single character in Unicode. White space. Some characters act like white space. I sent this bug to Opera last year, and as a handful of characters I could use as white space in Opera to pull off this attack right here. This would be great for a WAF. I mean, there's a lot of fun stuff you could do with WAFs, I'm sure. I just don't know any of them. That's the Mongolian vowel separator. It's a fun one. Specifications. Character set transformations can be a problem. Try to avoid them. Character set mismatches. That's the fast one. Thanks, guys.
Thanks, man. We appreciate it. Thank you.
Yeah. Hey, that watcher's available on our website. If you guys want, anybody wants to download it. I know you probably got to make you Windows Fiddler converts first, though, huh? If you can get it running on Mono, let me know. That'd be awesome.
If not, that's what we're working on there.
There you go.
Use some FaceTime with some of the ISA guys.
ISA?
Yeah, take some of the logic and dump it on ISA.
Yeah, that might be cool. I'd love to test some of that stuff.
Or some of the guys Joseph's work. Also doing logic-based detection of proxies. John Wolford and those guys. Yeah, you know them?
No. That'd be cool.
If you can get this stuff like